Okay, so let's start today's tutorial session. I hope everyone is able to hear me and see the presentation. Uh, if you have any issues, you can stop me anytime between the session and ask me any doubts that you have. So welcome to the third tutorial session of the course Problem Solving Through Programming in C. So this is a course which is floated in NPTEL by Professor Anupam Basu from the Department of CSE Tech Kharagpur. I'm Siddhant. I'm one of the 4 TAs who are in charge of explaining your doubts, conducting these sessions, which basically aim to explain your doubts and solve some sample questions, which will help you out with the assignments as well as with the final exam. Okay, so in this week's, that is week three's lectures, we went through, yeah, week three's lectures, we went through operators, different kinds of operators, that is arithmetic, relational, logical, assignment, and bitwise. You probably know you have been seeing this since childhood. The addition, subtraction, multiplication, division. This might be something new, and increment and decrement. So all of these are arithmetic operators basically, and this is something new you might or might not have seen really. So this modulus operation. So say I am doing a 5 modulus 3. That basically means that it will give a remainder after the division. So if I divide 5 by 3, the remainder will be 2. So 2 will be the answer here if you do 5 modulus 3. So this is a new arithmetic operator that you probably might not have encountered before. But so these are the different arithmetic operators that are present in C. So using those arithmetic operators, let us just solve some sample problems. So let's see, the first problem that we have is what is the output of the following program. So here we have a program where we are including stdio.h and we have a variable that is I, which is of type float, and we are initializing it to minus 3.0. Now we are what we are doing is we are initializing a variable k, which is basically we are saying that it should be I percentage 2. That is I modulo 2 operation. We are doing a modulo operation here, I modulo 2. Now we are printing this k. So what should be the answer here? That is, we are basically doing minus 3.0 percentage 2. This is what we are saying. So what should be the answer here? So the options are mentioned here. You can probably try to answer them. We're trying to do, we have a float variable which is I, and then we have a int variable which is k, and we are assigning it to I percentage 2. That is, we are trying to do a modulo operation between a float and an integer. Okay, so what will be the value of k here, as we have used a printf statement? What is the value of k that we will be getting? So these are the different options that you have. Can you just try to answer? You can unmute and answer. You can write it in the chat box as well. So yeah. Okay. Yeah, that it should be D. Some of you have answered correctly. So the answer here will be option D. It will be a compilation error, because if you have watched the lecture, you might have seen that this modulo operation, which is this percentage symbol when you write, it can be done only between two ints. Okay, that is between two integers only, and not between a float and an integer. So here, because we are trying to do a modulo operation between a float and an integer, this will result in a compilation error. So what do we do in this case? How do we debug this? This is the issue that we have. How do we debug this? So we could write something like in bracket int, then you could write minus 3.0, oh sorry, not minus 3.0, write I, then percentage 2. Sorry, I'll just write it again. K is equal to int in simple braces, that is parenthesis, then I percentage 2. So what would happen in this case? So this I is a float variable, but when we are writing it along with this int in braces, it becomes a int variable. This particular thing is called a explicit typecasting. So what we are doing is we are changing the type of I from float to int. So the data type of the variable I, we are changing it forcibly from float to int by writing this int in braces before the variable I. So that this process is called a explicit typecasting. So once we do that, this entire thing becomes an int, and then we do a modulo operation with 2, then we'll get an answer of -1. Okay. So in that case, when we print out k, we will get the value of -1. Is that clear to everyone? If you have any doubts, you can stop me anytime. Let me just check the chat box. Yeah, okay. Okay, so let's move on to the next question then. So the next question is that, okay, someone. Okay, fine. Sorry. So let's go to the next question. The next question is find the output of the following C code. So here we have four different variables, rather five different integer variables, four of which we have initialized. We have initialized A to be 10, B to be 3, C to be 2, and D to be 4. And then we have a variable called result, and this result variable we are writing it as A plus some expression of A, B, C, and D. So keeping in mind all the arithmetic variables and their operator precedence and associativity, what will be the answer of this following code when we try to print result? So let me remind you regarding the operator precedence and associativity, especially for this arithmetic operators. You have the star operator, the modulo operator, and the division operator have a higher precedence. I shouldn't be using this. Okay. So this is the order of precedence for these operators. So whenever there is a star operation, or that is a multiply operation, or a modulo operation or division operation, it will occur before addition and subtraction operation. Now this is the operator precedence for the arithmetic operators. Now what about the operator associativity? When there are different operators of the same precedence on the same line of the code, what will happen? So here the operator associativity is from left to right. Okay, so what does that mean? So let's solve this question. Has anyone done that yet? Let me check the chat box real quick. You can just, if you have solved this, then you can write the answer in the chat box. Okay, no issues. Let's solve it now. So so basically I'll just write it down first in terms of the values. So it is 10 plus 10 into some -3 by 2 percentage 4 plus 2 into 4, right? So this is what it is. So what we will do now is we'll see first the operator precedence. So when we see the operator precedence, we have so we have a multiplication operator here, we have a division operator here, and a modulo operator here. So this three will have a higher precedence over, and we have a multiplication operation here. So this 4 will have higher precedence over the other addition and subtraction operations. Okay. So now if we do that, if we do this operations first, so what would be, so we have the same precision. 15, yeah, right, 15 is the answer here. um, so okay, so we have the same operations here, which are having the same precedence, this multiplication, modulo and division operations, which is basically having the same precedence. So the associativity rule says that it will go from the left to the right. That means we'll evaluate in this manner. So when we evaluate in that manner, it will be 10 plus. So this will be evaluated first. So this particular thing, this minus 3, this is a unary operation. So this is a unary operator. I'll tell you this in the next slide what unary operator is. So it is basically acting on a single operand, and uh, it has a higher precedence than even the arithmetic operators. Okay, so rather should be operation. Okay, so this will be minus 30. Then we'll have by 2 percentage 4. So I'll do it one by one. So 10 plus, so it will be minus 30 by 15. So minus 15 percentage 4 plus 2 into 4. So minus 15 percentage 4. What should that be? Minus 3 plus 2 into 4. Then minus 3 plus 8. Okay, so this would result in 15. So here 15 is the correct answer. So is there any doubt how this expression is to be evaluated and so on? Is everyone clear with this operator precedence and operator associativity, the two concepts? Okay, operator precedence is basically when you have different operators, some operators will be evaluated first, some operations will happen first, and the other operations will happen after that. So here in this particular expression, this minus 3 is a unary operation because it is acting only on a single operand, which is 3 here. So it is just making it negative. That is, the sign of the integer is changing from plus to minus. So this is a unary operation. This has the highest precedence here. And then you have the multiplication operation, division operation, and modulo operation that is occurring. But all of those are used in the same expression. So what to do then? Then a concept called operator associativity comes into the play. So operator associativity for this arithmetic operators is from left to right. That means that when you have this multiple operations of the same precedence, that is these three operators that we have here, there are four operators that are of the same precedence, we will always evaluate from the left to the right. So this is the direction in which we will evaluate. So first, the plus operation is a lower precedence operation, so we will evaluate that later. First we will do minus 3, like this value has been taken, the value of this integer changes from positive to negative, and then we start with the operator associativity thing. So we multiply 10 with minus 3, that makes minus 30. That is the first step. Then we move on to the next operation, that is the division operation. So division operation, when we do that, it gives us minus 15. So after getting minus 15, the next, as we move from the left to the right, in all these cases we are just moving from the left to the right. So we'll have to do minus 15 percentage 4, which basically will be minus 3, because minus 15 by 4, if you do the division, the remainder is minus 3. So it will come out as minus 3. And then you have a 2 into 4, that is 2 multiplied by 4, which will give you an 8. So finally you got 10 minus 3 and 8, and all of these are addition operation or subtraction operation, which will have the same which will have a lower precedence and hence have been evaluated later after all this multiplication, division and modulo operations are over. Only then the addition and subtraction operations are taking place, and once you do that, you will get the answer to be 15 here. Is that clear? Okay. Okay. So I hope this is clear to all of you. If you have any doubts, you can write it in the chat box as well, or you can just unmute and speak up. Okay. Okay, so let's move on to the next thing. So we have the next kind of operators that we have seen are relational operators. So when it can be used to compare the values of two variables. So basically the relation between two variables can be found out. So here I am saying that is x is equal to y. So say I am saying is x equal to 3. Is the value of x equal to 3? So that's what I am asking. So the answer would probably be true or false. If x is actually 3, then you will have a true value, otherwise you will have a false value. So this way we have different relational operators with equality condition, non-equality condition, less than, greater than equal to, and less than equal to, which are pretty much what you have seen in math. Okay, so I don't think there will be any doubts here. So I'll move on to the next operators. I'll quickly cover all the operators first, then we'll solve questions. So this is something that if you are new to programming languages, you might have seen this for the first time probably. So these are called logical operators. So yeah, you want to combine two statements in some way. So you use this logical operators. Okay. So there are basically these three main operators that we have: and, or, and not. So say we saw relational operators just before, and say we have two such relational um, conditions, right? So we want to check that is x less than 5, and at the same time x is less than 10. So basically what does this boil down into? So x is less than 5, right? So this will return to, let me give you another example. Y greater than 3. So say here if x is actually less than 5, so this will be true. So if, let me just write that, true means 1, false means 0. Okay, I'll be using this notation. So say this is true and this is also true. In that case this will return a true. So that is a AND operation. And even if one of them is false or both are false, it will return false. So that is what a logical AND does. So only if both are true, it will return a true. If any of these are false or both are false, either of them are false, then it will return a false. So that is how AND operator joins two different relational statements. Okay. Then we have the OR operator, which basically for the same condition, if I just write it down, say this is true and this is true, so it will return a true. If either is true, it will return a true. If both are false, it will return a false. So in the OR operation, we see that if either of these conditions are true, then it will return a true value. If only if both are false, only then it will return a false value. And not operation is just, it will take the opposite of whatever you have. Say you have an operation, any operation, say this entire thing, it came out to be 1. If I had written a not of this, that is this exclamation symbol, this would have become 0. So 1 will become 0, 0 will become 1. So based on this not operator, just invert the values from true to false or false to true. Okay, I hope this is clear. If anyone wants to know how this came out to be, you can just search logic gates. Probably you will be able to know a bit more about it, how it came out to be this way. So you do circuits and many different things in order to find out how this exactly occurs. So logic gates, you could search with this particular thing, but I'll not be discussing it here. Okay, so these were the logical operators. Next we have assignment operations, pretty much familiar to you by now in the first 2 weeks lectures. So this is simple assignment operation. This is addition and assignment, subtraction and assignment, multiplication and assignment, division and assignment, modulo and assignment, and these all are called bitwise assignment operations. I don't think you will require to know this, but bitwise bitwise operators, okay, there are also bitwise operators. These are the assignment operators, which are pretty much familiar territory to you by now. But bitwise operations might not be something that you might be aware about. So if you remember, I had said that every INT will have say 4 bytes of information, right? For a 32-bit system, it will have 4 bytes of information, which is basically 32 bits. So, and if I represent say 1 byte here, sorry, 1 byte here, so it will have okay, 8 bits. That is 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So it will have 8 bits. So what this bitwise operation does, it acts on the bits directly. So you can, if you want, you can shift a particular bit value from here to here, or from here to here. That is this shifting operations. That is shift to the right, shift to the left. Similarly, you can do a bitwise AND operation, bitwise OR operation, or a NOT operation, or a XOR operation using like if you have two such bits, like two such bytes, or basically, yeah, you have 8 different you have two different variables. Say you have two character variables, and each occupies say 8 bits of information. Then you can do a bitwise AND. So this will have a AND. So here you will have some 1 0 0 1 1 something like that, and here also you will have 0 1 1, some binary input. So it will do a AND operation of this two, all corresponding bits, and you will get some value. So all of these are bitwise operations. I'm not sure if it is very much vital to you, but just for the sake of completeness, I'm just covering this. Okay, so these were bitwise operations. If you want to know more about them, you can just search how it is being used. It is quite useful in a few applications. Suppose in swapping numbers and so on, you can use bitwise operations to do it very easily. Okay. Okay, so a different kind of classification of the operators can also be unary operators, binary operators, and ternary operators. So unary operators, if you remember, I told you a bit earlier that that minus symbol could be a unary operator, right? So this is not a complete list, but it is kind of a sufficient list for the three different types of operators to explain them. So unary operators basically they act on one operand, that is say minus 3, minus 3. So that kind of, so basically minus x or minus x and so on. So one operand. Binary operation will happen between two operands, that is a plus b, a minus b, and so on. And then a ternary operation, ternary operators, there will be three operands. Okay, so it will be this ternary operator is actually quite interesting because this is also a conditional operator. But before going to the conditional operator, we have to know what exactly is a conditional statement. So we'll be covering that next. But before that, let's solve some more questions based on these operators that we have just learned. So let's solve this question first, which is on the left hand side of the screen. So we have this variable x, which is of integer type, and then we are assigning it to some value which combines both relational statements and logical operators and arithmetic operators, and finally we are printing out the value of x. So what should be the value of x after this code has been run? So you're free to unmute and tell me your answer, or you can also write it in the chat box. Okay, so let's see what exactly happens when you write this relational equations, right? You write this relational operators, what exactly happens? But let me also, before that, let me add up to the relational table or precedence table that I was writing before. So you have parentheses at the very top. Then you have this unary operations, binary operations. Then you have this subtraction, division, and modulo operations. Then you have the addition, subtraction operation. Then you have this relational operations. Okay. Then you have the logical operation. So this is the order of this is the operator precedence. Okay. So this is the operator precedence that we have. So parenthesis will have the highest priority, anything inside the parenthesis, and this is order. Yeah. Which okay, precedence. Okay, operator precedence is basically, say you have this many different operators in this particular line or in this particular statement. You have this less than operation, you have a plus operation, and you have this logical and operation, right? So if there are multiple operators like this in a single statement, in which way would you evaluate this expression? So this is the operator precedence. So here, according to this particular precedence table, first you would evaluate this addition operation, because apart from that you have this less than and the logical and operation, which are of lower precedence than this. So first you will do this plus operation, that is the addition operation. So once you do the addition operation, your expression will read something like 9 less than 8 and 7. Okay, after you do the addition operation. Now after doing this, you will see that what are the different operations left. So we have a less than operation, and we have a logical and operation. Now you see this less than symbol or less than operator is actually having a higher precedence than this and logical and operator. So we will evaluate this part first, because this has a higher precedence. So in the earlier example as well, we had this multiple operators in a single line. So there are some operators which will be evaluated first, and then some operators which will be evaluated after that. So it is an order of precedence, that is the operator precedence. So this is, in this particular operation occurs first, then we go to the next operation, that kind of a thing. Is it a bit more clearer? Okay. So here when you do a 9 less than 8, so definitely it is a false condition. So false condition here in terms of int would be a 0, and then we are doing a 0 and 7, that is logical and 7. So this is taken to be true. So let me tell you this. If you are, say you are writing say 0 and 7, so this is definitely false because it is a 0, but this will be true. Anything apart from 0 will be true. So if you had written 0 and minus 7, this would have also been true. Anything other than 0 will be considered as true. So only if you write a 0, it will be considered false. Anything other than that, any number other than that, whether positive or negative, will be considered as true. It might be fractional also, but still you can write 7.5 here or minus 7.5, it will still be true. Okay. Okay, so keeping that in mind, so this is false, and we are doing a logical AND with something that is true. So this will give us a false, because if you remember logical AND, it will give true value only when both the expressions are true. If either of them are false, it will give false. Okay, so here we get false, which in terms of int, because we are trying to save it in an int, so you will get a value of 0. So the answer here will be 0. Is that clear? Okay, fine. I hope it is clear to you. Uh, okay, so just keep this in mind. I think there is one question in the assignment as well related to this. You can Just remember this for that particular question as well. Okay, so let's go to the next problem that we have here. Okay, so this is what we call a ternary operation. Before that, let me just write down what a ternary operation is, or what ternary operator is. So we have some variable, and using, we are writing a condition, then, sorry, you're writing, then u2. Okay, so this set of operators, this question mark and this colon, this is called ternary operator. So here what will happen, if this condition is true, then this value will be saved in the variable var. Okay, this will come to var if it is true. Now if this is false, then it will go to this value. This value 2 will be stored in variable var. Is that clear? So based on this condition, whatever is written here, this entire condition, on evaluation of that condition, if it is true, then the first, this val1 will be stored in the variable, or if it is false, this the part after the colon will be saved in the variable. That is how a ternary operation works. So basically, if you have a simple condition, you can directly write a very compact statement for both true and false conditions, and save a save a value to a particular variable. Okay. So keeping that in mind, let's see this question. So we have an integer variable h, which has the value of 8, and what we are trying to do is we are writing a ternary operation statement. So we are writing another integer b is equal to 4 multiplied by 6 plus 3 multiplied by 4 less than h multiplied by 5. If this entire condition is true, then the value of b will be 4. If this entire condition is false, then the value of b will be 3. And then we are printing b. So what will exactly be the output in this particular code? Yeah. So the condition is this particular part, that is before the question mark. Okay, so this entire part is the condition. So you have to evaluate this first, and based on whether this entire condition is true or false, the value will be 4 or 3. Okay. So yeah, so this is basically, okay, so you think, okay, yeah, okay, yeah, right. So was everyone else able to follow this? So if you go into operator precedence, so here I have written the operator precedence, come back to this again. So here you see the multiplication operation is having a higher precedence than the addition operation, as well as with the relational operation, that is less than or greater than or whatever. So first we will evaluate all multiplication operation, and that too from left to right, because the associativity says that we have to go from left to right. So first this 4 into 6, that will be 24, then 3 into 4, that will be 12, and h into 5, h is 8, so this will be 40. So your expression will come down to 24 plus 12 is less than 40. Now next we will do the addition operation here. So this addition, because the next in the precedence table, the next is the addition operation. So this addition, once we do it, it will be 36, and then we'll do the relational operation with 40. So 36 is less than 40. Yes, that is true. This is the true condition. 36 is in fact less than 40. So the part which is after the question mark and before the colon will be evaluated, that is the value of 4, that is the value of 4 will be saved in the variable b. So when you print b, the answer will be 4. Okay, is that okay? So let's go to the next question. Okay, we have a few more questions here. So the first question here is, yeah, it's kind of similar. We'll be still using those precedence operation, the operator precedence that we were looking at in the previous page. So try to solve this question. We have a 10. This is logical OR operation, if you don't remember, and this is a logical AND operation. Okay. So try to solve this particular question, evaluate this particular expression. Okay. D. So I'm saying D. Okay. Okay. Let's see what the answer here will be. So if you remember, let me go back to the previous slide. So here I said anything that is within the parenthesis will be evaluated first, right? So in a sense, parenthesis has the highest precedence even before the operators. So here you see this entire thing is kept in one parenthesis and this in another set of parentheses. So first let us evaluate this. So 10 or 0, that is this part, that is the 10 part, is basically true because I said anything which is other than 0, it might be minus 10, plus 10, plus 50, minus 50, whatever. So it will be true. Anything other than 0 will be considered as true and 0 will be considered as false. Yeah, so this entire thing, this is a logical OR operation, so this will be true. If you remember the logical OR operation, only if both are false, only then it will give a false. Okay, and if even one is true, one of the conditions is true, then it will give a true value. So here, this expression will evaluate into a true value. So this part is true, or you can say it as 1 in terms of int. Now the next is just the other parenthesis just has 10, so we can directly open it up. There is nothing to evaluate there. So the next step will be 1 and 10, that is logical and 10. So this is true because it's not 0, so it's true, and this is true because it's also non-zero. So if both are true and we are doing a logical AND, so you will get it true. So this entire expression is basically true. So if it is, which one? No. In the true conditions is always if you do a int, like the true condition is considered as 1 in int, like when you try to save it as int, and the false condition is saved as 0. So in binary also, the true condition is saved as 1 and false condition is saved as 0. So 1 is always true, 0 is always false. Okay. So here, because the overall expression is evaluating into true and we are trying to save it into an int variable, that is x, so it will save it as 1. So x is equal to 1 will be our answer here. Is that is your doubt clear now? Yeah. Okay. Okay, so I hope you understand how this entire process is done and how this variables, or rather values, any non-zero. So basically any non-zero value will be true. Okay, here if you write any non-zero value, it will be true. Only if you write a 0, it will be false. And however, if you convert a true value into some integer or float or something, then it will take only one. It will not take any other integer like 5 or 10 or anything. It will take only one, because in binary true is 1, false is 0. Okay, so here x will be 1. Okay, so I have a very similar kind of a question only. So here we have a as 3 and b as 2, two integer variables here, and this is an expression that we are trying to do. It's a equality expression. Probably I'll rewrite it so that you can see it better. So it is a equal to b equal to 0. Okay, so this is the expression that you have to evaluate, and you are finally printing the value of a and b. So can you try to do this? Okay. And anyone else? Okay, some people are saying 0, 0. Okay. Well, let's see. So this is what kind of an operator? This is also a relational operator, right? In the same class as less than, greater than, equal to, not equal to, right? So it's a relational operator. Okay. Now we have two different relational operations going on here. First, we have a equal to b, then again equal to 0. So two different operations are there which are having the same precedence, that is this equality operation. It is having, both the operators are having the same precedence. Then what will you do? We'll go to operator associativity. Now operator associativity says, for this particular, for relational operators, the operator associativity it is from left to right. Yeah, from left to right. So because we have operators of the same precedence here, we'll evaluate from the left to the right. So we'll start from the left. So a equal to b, first we'll evaluate. So that basically amounts to 3 equal to 2. It's not, it's false, right? So it's false, which is basically 0. And then the other thing is 0 is equal to 0. So this entire thing came up to be false. This, okay, let me just write that down. This entire thing came out to be false, which is basically 0. And then the next operation is between 0 and 0, and it is a equality operation. So what will this give? This is true, right? 0 is equal to 0, so yes, it is true. So this will be 1, because a is a int variable. So this entire expression evaluated to be true, and hence the value saved will be 1. So when you print it, it will be 1 comma 2. Okay, your a will be printed first here, and then comma b. So b is still 2. The value of b has not really changed. And whatever you are assigning is being assigned only to a. So a is 1, or it was found out to be true. This expression was found out to be true. So the value of 1 was saved in the variable a, and then b is 2 as before. So 1 comma 2 will be the answer here. Is that clear to everybody? Yeah. Okay. Okay. So we'll move on to the next question. So let me just, okay. We are already getting answers to this. Okay, cool. Yeah, so this is a comparatively easier one. So we have simply same kind of logical operators. This is the not operation, if you remember. It will make a true into false or false into true. Just, yeah. And this is a logical AND operation. So here we are taking two variables, integer variables, x is 17 and y is 1, and we are this is the if condition. Okay, I have not really covered this. So this if this is true, if this condition is true, then this is evaluated. If it is false, then this is evaluated. So this is what if and else basically means. So this is the true part and this is the false part. Okay, so in this case, let us really see what is happening. First, we'll evaluate the ones in the parenthesis, not of 17. 17 itself, as I said, it is true, but not of that will be false, right? 17 itself is a true value because it's non-zero, it is true. So not of 17, that is not of true, will be false. Now, basically, the expression comes down to not of false and y. So not of false is again true. So we are doing true and y is 1. So 1, so let me just replace this as 1. So 1 basically means true. So true and true will give you true, right? Because it's a logical AND operation. So this entire expression it evaluated to be true. Now if it is evaluated to be true, the value of x is to be printed because this is the line that will be printed if it's true, and this is the line that will be printed if it's false. Okay, so x will be printed. So your answer here will be A, 17. So I think a lot of you have already answered it correctly in the chat box. If you have any doubts, you are free to answer that. Okay. Okay. Uh, okay. So let me again redo that. So first, this expression, if let me just write down this expression again. Okay. And y. Okay. So this is the expression. Now I'll just replace it with its variables. So the next step will be not of 17 and 1. Okay. So what not of 17? So 17 is a non-zero value. Non-zero value means it is true. Okay. Now not of true means it is a false. Okay. So this entire part within the parenthesis, this got evaluated into false. Okay, because this is true. Not of true means false. It just converts true to false and false to true, right? So now the expression is not of false and 1. So again we have the not operation here. Now operator associativity comes into place because both of these are the same precedence. So these are both logical operators, which is not operator, logical and operator, logical or operator. For this the associativity is also from left to right. Okay, for logical operators. So again the not operator will be evaluated first. So the not operator, it is acting on false, so it will become true now because yeah, not of false is true, and then and 1. So 1 is also true, right? Because it's non-zero, it is true. So basically you are evaluating true and true. So both are true. So the return value from this operation will be true. So true basic. No. The non-zero condition, non-zero number means it will be considered as true. So here, if I write 17 and 0, so it will be evaluated basically as true and false. Okay, so if it is, yeah, and uh, yes. So according to AND condition, if both are true, only then it will return true. Otherwise, it will be false. In all other cases, all other combinations, it will be false. Okay, you are correct. So here, that is what happens. It is both are true. So this AND operation will return it true, and true means this first statement will be evaluated, which is printing x. So x is printed 17. So 17 will be your answer. Is that fine? Yeah. Okay. Okay. So yeah, I solved the question on if statement already, but yeah. So this is how if condition is basically used. This is the syntax. So you write if, then in braces in parentheses you write the condition, like we had written here some condition we had written, right? This not and y is something. So this is our condition, and we write whatever is to be executed next within curly braces. And if we have multiple such conditions which need to be separated from each other, so we'll write condition 2 and another block of code here, which will be executed only if condition 1 is false and 2 is true. Okay. So if 1 was true, it will not even check this next conditions. It will directly go to the end. Okay. Now if 1 is false, only then the second condition will be evaluated. If the second condition is true, this block of code will be evaluated. If it is false, if condition 2 is also false, then it will come to the else block. Now this if both condition 1 and 2 both are false, only then the else block will be evaluated. So here the ternary operators basically do a simplified if else, right? Now like you can appreciate this, that the ternary operators that we have seen, the ternary operation rather that we have seen is doing the work of a simplified if else statement, because here we have a condition which is basically condition 1, and this is the uh, true block, this is the false block, right? So in simplified cases like this where you just want to save some values or evaluate a very simple expression, you can use ternary operators instead of using a if else operation. Okay, so this is what if else statements are. So keeping this in mind, let us solve this question. So here we have three different integer variables. We have a is equal to 4, b is equal to 15, and c is equal to 29. And you are writing the condition to be c is greater than b greater than a. So your condition is this. Okay. 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 Um, here. Okay. Anyone else wants to answer this? So here also the operator. Okay. 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 So let's see what happens here. So 29 greater than 15 greater than 4, right? Okay. So now both are greater than operations, that is relational operations, and now operator associativity, as you remember, it's from left to right. Okay, you have two similar precedence operations, that is the greater than operation, and the operator associativity for relational operators is from left to right. So we'll evaluate like this. So first we'll evaluate 29 greater than 15. So 29 greater than 15 is true, because 29 is in fact greater than 15. So this part is evaluated. Now we have to evaluate the second part. So true means it will take a value of 1, and it will compare it with 4. Here you can see it will return a false value, right? So because this entire condition now came up to be false, it will print the else part. So this condition, it is evaluated, it turned out to be false. So it will go to the else part and it will print whatever is there in the else part. So here the answer will be false. So like it seems directly that 29 is greater than both 15 and 4, so this should be true, but the computer doesn't see it like that. So the computer only knows this associativity and precedence. It cannot think like us. So we also need to evaluate in this manner, that we need to think that the operator associativity for the relational operators is from left to right, and we have similar operators here, so of the similar precedence. So we need to evaluate this expression from the left to the right. First we evaluate this 29 greater than 15, and that turned out to be true. Yes, that is true. And true means it has a value of 1 basically. And then we evaluate the next condition, 1 greater than 4, which is false. 1 is not greater than 4. So this entire condition turned out to be false. So here the false in capital will be printed out. Is that clear? Yes. So this is the operator associativity. So basically, let me go back a few slides. I had written that. Okay, so okay, yeah. So we have this precedence table, right? So this precedence, or otherwise, sorry, yeah, I have this table for you to see. Um, okay, so we are talking about this relational operators, greater than, so less than, equal to, greater than, equal to. So this has a associativity of left to right. That means if you have an expression, say in that expression, you have multiple, say, right, not this way. Okay, if I had written the expression like this, and these are all of the same precedence, so this is also written in the manner of precedence. Okay, so yeah, so you have this c greater than, so you have the same precedence, that is this greater than and greater than equal to symbol, they are having the same precedence. When these operators having the same precedence are used together in a single expression, you then go to the operator associativity. Now operator associativity says that it should be evaluated from the left to the right. So you will go in this direction in evaluating. First you will evaluate this, because this is the leftmost part, so you will evaluate this first. So in that case it was 29 greater than 15, which would be true. 29 is greater than 15, so it would be true. And then we go to the second part, which is basically true, which is 1 greater than equal to 4. So this is false. So this entire condition basically came up to be false. Now, this is, if this is false, then we are printing this false in capital. So this will be our answer. Is that more or less okay? Oh. Okay, so let's do, this is the last question for the day that I have. This is also quite simple. Just need to think about what I said about if else if statements earlier. So here we have a integer variable 10 and the first condition. So this is condition 1. So condition 1 is that x is greater than 0. So if condition 1 is true, it will print this particular block. Then it goes into a if else statement where it checks again x greater than 0 and it prints something else, and then it gets over. So there is no else block here. So yeah, I also need to mention that if you are writing a if statement, only the if condition is necessary. Like if you don't write a else condition, it will still work. Anything that is within the if condition will work. If you don't have anything as a else condition, that is fine. You don't need to mandatorily write a else condition and have a block of statements inside that. If you're writing if statement, that is also fine. So keeping that in mind, can you answer this particular question? What the output from this code will be? Okay, so this is condition. Okay. Anyone else? So you're basically saying that both this will be printed, right? Because x is greater than 0, so both condition 1 as well as condition 2 will be true and this will be printed. That's how you're thinking, right? When you said that C would be the answer. Okay. Okay. But here, if let me just go back one. So here, just see what has been written in the comments. So if condition 1 is true, this block of code will be executed. Okay. Now, the block of code after the else if statement will be executed only if condition 1 is false and condition 2 is true. So if I go back to the question, so this is condition 1, this is x greater than 0. Now this is true, condition 1 is true. So this particular statement is executed, that is this printf inside if slash n, right? So we have this output inside if, okay? Then it won't even go to this else if statements. Why? Because condition 1 has become true, so it will straight away exit the if else block. So for this statement to be printed, this statement, condition 1 has to be false and condition 2 has to be true. Only then this particular statement will be printed. So condition 1 itself is true. So this particular expression, this particular statement will never be executed, this printf statements. Okay, even if this condition is true, it does not matter. Condition 1 has also already become true. So in this case, it only inside if will be printed. So the answer will be A, okay, inside if. Okay. Like I said, else statement is not really required. So you can just have some if, say I am writing some condition here and some statements here, some block of statements, and so it's not necessary that I will always have a else statement. Okay, and it's not mandatory to use a else statement. So it's fine. That is not a problem. So anyone else has any queries with this particular example? Okay. Okay, I hope whatever has been covered, the example questions and so on, will be helpful for you with the assignments as well as later on in the final exam. From this week onwards, you had, I think, some coding questions have also started, but it was fairly basic, so I didn't cover it. We'll be covering some coding questions from the next tutorial session onwards. Okay, so that it helps you out with how to write the code and so on. Okay, so if anyone else has any doubts related to whatever has been covered the in today's tutorial sessions or the previous ones, you can just contact me now, or you can write your questions in the forum as well. Okay, if anyone doesn't have any questions, then we'll end the session here. Okay, thank you for joining, everyone. We'll meet the next week, same time, 6 to 7. Okay, sure.